This is Algebra 2 with trig. We're working on 1C.4c. We're going to determine the best method for solving quadratic equations. We're going to first work with the zero product property. To solve by using the zero product property, the quadratic equation must be factorable. So we're zoomed in here and we're looking at factoring x squared plus 7x minus 18. We know that negative 2 times 9 multiplies to be negative 18 and adds to be 7. So we're going to put our negative 2 and our positive 9 right into the parentheses. And x times x would make x squared. So now if we were to test this, FOIL would produce our trinomial from above. Since it equals 0, notice we're not making the equals out of nothing. The equals is part of the problem. So we're going to set this equal to 0 and add across your 2 and subtract across your 9. We solved this quadratic because we could factor it. If it's factorable, that's typically the fastest way to solve. How would we go about factoring this one? There is not a GCF in everything. Since there's no GCF, I should bring my 3 back across.
So if there was a GCF, you wouldn't bring it?
We need to have all 3 terms on the same side of the equal sign when you have a B term. When you're going to factor, you need to have them all over on the same side of the equal sign. You need it equal to 0. So now we need to do A times C. If we're going to use factor by grouping, that's the method for factoring. And this is working out pretty well. What multiplies to be negative 12 and adds to be negative 11. Yeah, 1 and negative 12. So we're going to put that 1 and negative 12 and that's going to replace our negative 11. 1x, which is a positive 1x, minus 12x's, that gives us this middle term. Then we bring down the 4x squared and the minus 3. We're going to circle both groups because this is called factor by grouping. We're going to group these 2 pairs up. Factor out what you can. That leaves you with the 4x plus 1 on the inside because x times 4x is 4x squared and x times 1 is x. You've got to have this place value holder. Bring down your sign. What can you factor out of the next group? You can factor out a 3. So negative 3 times 4x makes that negative 12x, and negative 3 times a positive 1 makes negative 3. So then we bring down our x minus 3, and you bring down your 4x plus 1. You don't have 2 different 4x plus 1s come down. Just bring down one side. It's like factoring out the 4x plus 1 out of this whole line, and then you have left over the x and the 3. So, because your two binomials are equaling to 0, we're going to set each one equal to 0. You would subtract the 1 to get negative 1 divided by 4 gives you negative 1/4. So what makes factoring an advantage? When you can take the A times the C and add to B. When that happens, factoring is your advantage. You can factor pretty much from now on. You can factor if your A times your C equals your B. It's even easier if the A value is a 1. When the A value is a 1, you can just figure out what those factors are, 1 times 18, and what's going to multiply and add. You can just drop them in. But when the leading coefficient is not a 1, it gets a little bit more complicated. This method we're using is factor by grouping. You could use guess and check. Probably wouldn't have been too bad. All right, let's take a look at completing the square. To use completing the square to solve a quadratic equation, it's helpful for the B value to be even. It's helpful. It's not required. It's helpful for it to be even. And the A value to be 1. It's helpful for the A value to be 1. Not required. If you don't have either one of those, you might stay away from completing the square because it starts to get more complicated. Let's give this a try. So we know when completing the square, we don't want to bring the 14 back across. We actually want that 14 on the opposite side. We want the x squared term and the x term by themselves, at least isolated. So we're going to take our b divided by 2 and square it. 10 divided by 2 and square it. So we take this 25 because it was a positive 10. It's 10 divided by 2, square the 5, which is a positive 25. So we're adding that right after our b term. We also have to add that to the other side of the equal sign. So x squared plus 10x plus 25 is x plus 5 squared. That becomes 39. Take the square root of both sides. So you're going to be left with x plus 5. And we subtract our 5 over. The square root of 39 cannot be broken down. So that's our solution. Notice how this has a radical in the answer. That's a big hint to you that you cannot factor it. Okay, this one is a little tougher. So we look at this for a moment and we say 4 times negative 5 is negative 20. negative 20 that adds to be 12. Nothing multiplies to be 20 and adds to be 12. You think for a moment that 10 and 2 might work, but the signs would have to be the same to get to 12. 10 and 2 would have to both be the same sign. Your signs have to be opposites. So you can't get to negative 20 and to 12. So factoring is not going to work. So we're going to try completing the square. So we're going to move the 5 to the other side. Now, I gave us a hint in the beginning that this was going to be a little bit more tricky to work with. Because the A value is not a 1, we can't have the 4 be here. We have to make it a 1. So we're going to factor that A value out. And unfortunately, that gave us an odd value on the inside for their B term. But we can still complete the square. It just makes it a little tougher to work with. We take our B term, divided by 2, and square it. Well, we squared this before. How do you square a fraction? Without a calculator, how do you square a fraction? We get 9 because you square the 3. We get 4 because you square the 2. So that 9 over 4 is the value that we're going to put inside our parentheses. What are we going to put on the opposite side?
No. Add it. 9 over 4 times 5. Add it. 4.
You've got to watch by putting the 9/4 in here. It is actually 4 times 9/4. By putting the 9/4 inside these parentheses, the left-hand side of the equal sign has actually gone up by a much larger number than just 9/4. It's gone up by what? This becomes a 9. It's 4 times 9/4. So think about your 9/4 times 4. 4 over 1, nice. And they cross off, and it becomes 9 over 1, which is just 9. So we are going to add a 9 to the right-hand side. So this is going to be 4 times what value? What value goes inside as our binomial squared? It's always the value that you're squaring is going to be in here. You can think about 3 over 2 times 3 over 2 gives you 9/4. And 3 over 2 plus 3 over 2 gives you 3. That's 1.5. 1.5 and 1.5 is 3. Nine and 5 gives you 14. Well, we're going to divide by the 4. X plus 3 halves squared equals 14/4. When we take the square root of both sides, you can take the square root of the bottom, but you cannot take the square root of the top. And that's kind of good. Otherwise, we'd have to rationalize the denominator, so we don't want to worry about that. So this works out pretty good. Subtract your 3 halves over, and that's the best you can do. That one's a bit more challenging. What makes that challenging? The fraction, when you have a B term being negative. So perhaps when, or a b term, being odd, not negative, but odd. When the b term is odd, you might prefer not to do completing the square. And there could be another option. Tomorrow we're going to learn about the quadratic formula. We don't have the quadratic formula at the moment, so we're not going to worry about this. But completing the square works really well when the a value is 1 and the b value is an even. That's what we set up here. Over here we had pretty much the opposite. We had an a value not being 1 and we had a b value that wasn't even. It was still doable. You could still do the math. It makes it a little bit more challenging. Typically we would consider that not a great one to complete the square for. Unlike factoring, if factoring doesn't work, you can't do it. But if completing the square, it's always going to work. It's just how clean it comes out. How simple the process is. But there was no other process that we had for calculating this, so this was our best choice. Tomorrow we will work on quadratic formula. Then we can come back and visit the completion of these notes.